Welcome back to Cloud Computing series. In this video, we'll be discussing the important topics of fourth module, that is cloud security. We'll be discussing all important questions, important topics from exam perspective. And if you have not watched my previous video, we had discussed the passing package and most important questions from VTU exam perspective. So as a part of that, we'll be covering the fourth module topics here. So let's get started. The first topic which we have is cloud security risk. So we'll understand what cloud security risk is, what are the types of threats and cloud specific threats in general, and how do we mitigate these risks. So firstly, we'll understand the definition. So cloud security risk, and why do we need, what is cloud security risk, and why should we overcome these risks. So we know that as and when we are storing the data or storing the information over cloud, a third person or or an attacker has the access to the internet firstly, and thereby by making use of technology he can also get our data. So it is very important to safeguard our data which is present on the cloud, not just the data but all the cloud computing resources or the cloud services which are being provided. So cloud computing security faces several risks, both at the user's perspective and from the provider's perspective. So the traditional security risks include the risk associated with systems availability, concerns around the third party control of data. So it is very important to safeguard our data and mitigate the risk which is associated with cloud computing. So we'll look into the traditional security risks or the traditional security threats which are present in general. So the first one is user side threats. So users must secure their devices firstly. They must secure their infrastructure, their hardware. So by it is very difficult to secure your hardware and your devices and all. So it becomes challenging when there are few components which are not in our control. So thereby it is a risk. Then we have authentication and authorization. So proper access control is very important. So along with that, different levels for different individuals in the company should be given access. So thereby again it is very hard to integrate the security policies here, and even it becomes difficult for the cloud provider also to authorize who is accessing the data and authenticate it further, whether the person is a valid person or he is not a he's a attacker or something. So again it is very important. Then we have cloud side threats. So we spoke from the user perspective, we spoke from the cloud providers perspective. Now we'll speak from the cloud side perspective. So cloud services are vulnerable to the traditional attacks, like phishing could be there, SQL injection could be there, cross-site scripting could be there. So even virtualization also adds up to this complexity, because you're sharing the resources. No, it can be exploited or used by someone who's not supposed to use it. So again, there is a threat from the cloud side also. What are the availability risks? So the first one is cloud system failures. So here the cloud services can face downtimes sometimes, because suppose if there's no electricity or if the system has gone through failure or something. So data lock-in can also affect the business continuity if a provider fails to do that. So again, system failures or cloud system failures are the availability risks. Then we have third party control. So as I told, cloud provider may subcontract the resources. So there is a risk of data loss or data breach can happen if third party are getting access to it. Third party is not trustworthy enough. So thereby again there is a risk here. Next, we'll see what are the cloud specific risks. So these are important from exam perspective. So they can ask what is cloud security, and what are the types of cloud specific risk which you'll encounter. So the first one is abuse of cloud resources. So criminals can misuse the cloud resources for various activities like sending malwares or distributing the spam messages, accessing your data and all of that. So you're abusing the cloud resources here, not making legitimate use of it. So this is one of the threat. Then we have shared technology risk. So as we spoke just now, the virtualization topic, because you're sharing the resources in virtualization, a third person can access your data. So thereby there is again a threat here. Next we have insecure APIs. So cloud service APIs may not be providing the adequate security which is required, like authentication, monitoring, and all of that. So again, those are insecure. So thereby there is always a threat. Then you have insider threats. Insider threat means the cloud provider might make use of your data. He might take the sensitive information, whatever you have stored in the cloud. So again, it is a risk, right? Then you have data loss and leakage. So there is a risk of losing your critical data, because if electricity goes or some failure is there, or suppose you have exceeded the storage, some such problems could be there. So in such conditions, no, there won't be any backup also. So could lead to data loss, or at times when the storage exceeds, there is a chances of data leakage happening. Next we have is account hijacking. So cloud users may face threats of credential theft, which could lead to unauthorized access to the cloud services and all. So your account is being hijacked by a third person. So all these things are the common cloud specific threats which are encountered. How do you overcome these? So the Cloud Security Alliance (CSA) has identified key threats like malicious insiders, insecure APIs, account hijacking, and all of these. All of these are cloud-specific threats. So this security guidance, their security guidance for cloud computing offers advice on to how to minimize these risks. So this Cloud Service Alliance (CSA) will tell us to CSA will give us advice as to how to minimize these risks. And to address these security concerns, it is very important to establish a robust security protocols. Protocols in the sense there has to be a strict rules and regulations which have to be followed by the users, by the cloud users, by the cloud providers, and in general whoever is accessing the cloud infrastructure. And we have to ensure that there is transparency in the provider's operations, and we have to be aware of the new attack vendors unique to cloud computing, such as the multi-tenancy risks and data control challenges. So this was about mitigating risk. If you see this figure, it speaks about the surfaces of attacks in cloud computing environment. So in this first one we have is the user cloud. So here the user will request resources from the cloud, and the potential attacks can occur due to this during this conversation only. That is first step. Next we have is a service user. So service user, the service will interact with the user, and attack may target the service for the user side, such as phishing can happen, or SSL certificate spoofing can happen, and all of that. Next we have is the cloud user. In the cloud user, the cloud infrastructure can also be a source of attack on the user, such as the attacks from the compromised cloud resources can happen here. Next we have is the service cloud. So here service will interact with the cloud infrastructure to manage and request various resources. In such conditions also the attack can happen here, such as the privilege escalation or data distortion can happen here. Next we have is the cloud service. So cloud infrastructure can attack the service, for example, through privilege related attacks or data injection and all of that. So these are the surface of attacks in cloud environment. So the combinations between these key actors. So your key actors are the users, service, and cloud infrastructure. So we have seen the combinations of each of them here. So this was about the surfaces of attacks in cloud computing and how to mitigate the risk, and in general about the cloud security risk. Moving on further, the next topic which we have is security, the top concern for cloud users. So this could be a 5-mark question, or at times it could be a 10-mark question. If it's a 10-mark question, you need to elaborate it properly, elaborate each and every key user concerns, and then how will you minimize these risks, what is the solution, and all of that. Mostly it will be for 5 marks. So let's see. So security remains the top concern for cloud users, because see, you're trusting the cloud provider, you're trusting the cloud blindly, and you're uploading all your data or using all the resources which are being provided by the cloud. So here security becomes a top concern for everyone who's using the cloud resources, right? Suppose I've stored my files, I've stored my valuable documents, account my transaction documents and all of that on cloud, and a third person is accessing it, then there might be chances of me losing my bank details and all, right? So that's why security is very important when you're storing something over cloud. So security remains the top concern for cloud users, as they are prone to having full control over their sensitive data within a security parameter protected by the corporate firewalls. So even if you have the corporate firewalls, there are chances of leaking of your sensitive data. So however, in cloud, they must extend trust to the cloud service provider CSPs, which will prevent significant shift in the responsibility. So you have to blindly trust the cloud service provider CSP. So the major security concerns included here are the unauthorized access, data theft, loss of control over a data life cycle. So you might lose the control to access your data. The your credentials might be hijacked there, or they might be changed according to the attacker's convenience. So all such threats, all such security concerns can happen with your account or with your cloud storage. We'll look into what are the key user concerns in detail. Okay, so the first one is unauthorized access and data theft. So data stored in the cloud is vulnerable than during the processing or when you're storing and all, because here the servers will have access, so they can easily access your data, and the unauthorized persons can also access your data. So to overcome this, there has to be a robust security. Server should be secure enough to prevent unauthorized access. Life cycle. So data life cycle means right from the process you are uploading the data to cloud, and the data is being processed here, and required operation is being performed here, and after that you delete the data. So this entire cycle is considered as data life cycle. So during the data life cycle, once your operation is done, you're ending the life cycle there. So it is not sure that your data has been fully erased or not, even after termination, whether it is fully deleted or not. So backups performed without you knowing can also happen, right? So the data could be accessed by someone else, or it could be exposed to the third party. So there is again a risk present here. Then we have lack of standardization. So interoperability is a major issue here, because users will face challenges like how to retrieve the data if CPU goes offline, how to manage the price hikes by the CSP, and what are the costs of migrating from one provider to another provider. All these are happening due to lack of standardization. So again, this is a key concern. Then we have auditing and compliance. So full audit trails are very challenging in cloud environment, and compliance with the existing laws like for privacy, security regulations is also very complicated in general. So the existing frameworks like FIPS, FISMA, all these things are not that easy to implement in our day-to-day lives. So they are not easily extend to the cloud services. So again, it is a threat. Then we have autonomic computing risk. So we know as the new technologies like autonomic computing are evolving, so there is always a risk of self-organizing, self-optimizing, self-repair. All such things are there. So it is very difficult to track the actions or identify what are the vulnerabilities. Then we have multi-tenancy. Multi-tenancy means many people are using the same resources, sharing the same resources. So there is a chance, if there is a chance that you and me both are sharing the same resource, sharing the same server, and I can access the data through, if there is slight data breach also happening, I can access your data. So there is a chance, when there is a high chance of data breach to happen when we are sharing the resources over a cloud domain. So that's about multi-tenancy. Then you have legal and privacy concerns. So cloud computing will operate in a complex legal environment with data like having multiple having multiple rules and regulations over the data. It also depends on the area where you are there and the type of services which you are accessing. So there is a question which always lies. So what is a proper rule? What is a proper law enforcement? Is there anything existing in the government? So again, legal and privacy concerns are always there. So what are the user actions to minimize the risks here? So first one is to evaluate the CSP security policies. So here users should always review the CSP's security measures and their compliance with the privacy laws. They should check if they are proper or not. Then analyze the stored data. So here users should always assess the types of data they are stored and processed on the cloud, especially when you're storing the sensitive information. Then we have clear contractual obligations. So you have to the contracts with the CSPs should define properly. Like they should have the CSPs obligations to handle your data properly, to handle your information securely, and the liability. If something happens to my data, you should be responsible. CSP's liability is again a main thing here. And then data ownership and geographical storage of my data, backups. Again, all those things are there about the clear contractual obligations. What are the solutions for data protection? First one is avoid cloud processing for sensitive data. So as far as possible, users should avoid processing highly sensitive data in the cloud. So although it's not feasible for all the applications, but then if you want your data to be that confidential, you should not opt for cloud. Second one is encryption. So it is always suggested that you encrypt your data before storing it over cloud. So again, public key encryption or the symmetric encryption, many techniques are there. So if you encrypt your data and make use of the secret key, sharing it, then it makes sure that your data is safe, or even over the unreliable network or unreliable channel when you're transferring your data. So this was about the solutions for data protection. So we can say that although cloud provides a lot of benefits, there are these drawbacks also. So security is our biggest concern. Moving forward, the next topic which we have is privacy and privacy impact assessment. So privacy refers to the right of individuals or organizations to control and protect their personal or proprietary data from being disclosed to someone without their consent. So I have stored my documents over the cloud and it should not be accessible by you. So that is what privacy means. So privacy is the basic human right by many nations. So again, it varies from the laws and the regulations varies from place to place, right? So in general, we can say that it is a basic right. So you're staying at your home and you're in your room, so it's you need privacy, right? So the new threats that are emerging. So as the technology is evolving, there are new threats that are emerging even with the cloud security. So in this digital age, with identity theft being a common risk due to stolen or misused personal information. So what are the key privacy concerns related to the cloud computing? First one is loss of control. So once the data is stored on a CSP server, so my control, I might lose my control over the exact location and the duration of my data storage. For example, with the servers or with the services like Gmail, I cannot control where my data is stored or how long emails are retained in the server backups. So although I know it is 60 days only in my local cloud, but then after it gets deleted in the main server, I don't know how long it will be there. Next I have is unauthorized secondary use. So CSPs may use the data for purposes beyond their actual intention. They can make use for the targeted advertising. So we receive all these spam messages and all. No? So such things can happen. So the secondary use is not preventable. You cannot prevent it because there is no technological solution to stop such things. Then we have dynamic provisioning and outsourcing. So CSPs will often outsource our services, which will thereby have issues like lack of transparency about who is getting the access of my data and what is he doing with my data. Although he's giving the service, but then there are chances of him saving my data for further not further wrong usage or something like that, right? So all such things can happen. Next, I have legal and legislative framework. So different countries have varying privacy laws, with some have more aggressive than the others for protecting the personal data. For example, the European Union, so they enforce strict regulations, including the right to be forgotten, which allows individuals to have their data erased from the internet permanently. So this was about privacy. Next we have is privacy impact assessment. So privacy impact assessment is again an important topic, PIA. So privacy impact assessment can be asked together. So privacy impact assessment is a tool to identify the privacy risk in the information system. So PIAs are critical for ensuring the privacy is built into the systems from the start rather than retrofitted. So PIA process involves the following things. So during the end stage or after you have stored the data, in such conditions, if you are trying to inculcate the security aspect, it becomes very difficult. So right from the scratch only, if you are uh, embedding the privacy aspect, it is preferable. So we'll look into the steps as to how the privacy impact assessment is performed. What are the steps? How the process happens? First one we have is notice. So organizations must provide clear information about what data they have collected, how they will use the data, and if the data is being shared, who is accessing my data. The third parties, whoever is accessing my data, all should be notified to me. Next I have is choice. So users should have the ability to choose how their data is being used, especially for secondary purposes like sending the spam mails, marketing, advertising, sharing with the external entities, and all of that. Next is access. So users should be able to review the data collected about them and correct inaccuracies or deleted information if necessary. They should have complete access. Then you have security. So organizations should take reasonable steps to protect user data from unauthorized access or data breach happening. So these are the four steps which are involved in the privacy impact assessment. Next we have is proposed tools for privacy management. So it is very important to manage our data properly, manage our privacy properly, and there are certain tools which have been specified. So the first one is web-based PIA tool. So this tool will facilitate the evaluation and control of privacy risks. So it will gather the input from various sources, generate a comprehensive PIA report covering the transparency, security, and cross-border data flow. So from this report, I'll be able to understand whether my data is safe in that particular cloud platform or not. So the privacy aspect is being dealt here. Next we have is knowledge-based and rule-based system. So it supports the PIA tool with expert knowledge and guidance. So it will help us to evaluate the privacy risks based on specific legal and regulatory frameworks. So by making use of the standardized legal and the regulatory frameworks, it will further help me to understand, it will support the PIA tool to generate a report or generate an analysis as to how safe my data is over the cloud. So it will generate necessary actions also to address the identified risks. So after identifying the privacy risks, it will also suggest me what could be the counterparts for such risks or for such privacy concerns. So proactive approach. So we have to address, so it will address the privacy concerns early in the development life cycle. So when you cut down the threat in the earliest stage, it will be preferable, it will be safe for you to perform the transactions or perform the processing later on. But then if you're doing it at the last stage, it is understood that your data has been misused or it is leaked into the network already. So it is very important to safeguard your data at the early stage of development life cycle, and then along with that to reduce the need for costly modification later. So yeah, these two are the proactive approaches. Next, what is the importance of privacy? So cloud computing poses unique privacy challenges due to the third-party storage and potential loss of user control. We have seen how does the user control shift and all. So the strong legislation, transparent policies, and tools like PIAs are very important for safeguarding our privacy rights. So this was about the importance of privacy. We'll look into the benefits of conducting PIA. So the first one is proactive privacy management. So we are embedding the privacy rules from the design stage and avoiding any costly changes which has to happen later. So in the earliest stage of the development life cycle only you are inculcating the privacy rules here. Next we have enhanced compliance. So we'll align the systems with the legal frameworks like EU's GDPR or UK US safe harbor agreement. So when you're standardizing, when you're aligning your system with the legal framework, it means that you are following the standard security features, right? Thereby, if you are following the standard security features, your data will be safe. There won't be chances of security risks and all happening. Then you have improved trust. So it will demonstrate a commitment to protecting the user privacy or and fostering the consumer confidence. Thereby, again, by making use of PIA, that will inculcate the trust in humans or in the users, in the consumers. And this was about trust. This was about the privacy impact assessment topic. Moving further, we have trust. So trust is a crucial aspect in cloud computing. It is similar to its role in the other online activities. Trust is very important. It is based on the resilience of. It is based on the individuals or organizations which place on the character of ability, strength, or trust of others. So trust will facilitate cooperation. It will reduce the conflict, decrease the transaction cost, and foster adaptive organization forms. So we'll look into what are the key aspects of trust. First one we have is risk. So trust is built on the perception of risk. That is, there is uncertainty about potential loss will make your trust necessary. So if there is a risk, you'll think about the trust aspect, right? So without risk, there would be no need for trust. Next we have is interdependence. So trust also depends on interdependence because one entity's success will rely on the action of other. This like it is like a chain. So this relationship is key in the cloud services where a user will depend on the CSP for data storage, security, and availability. So you're depending there for for many operations like data storage, security, availability. Thereby, it is interdependence happening here, right? And there is a risk which is associated with this. That's why trust plays an important role. So without risk and interdependence, trust has no impact only. Next, we have phases of trust. So first one is building trust or building phase. So trust is initially formed based on the initial interactions or promises which are provided by the companies. Next we have is stability. That is, trust becomes stable and established over time, as in when we are interacting with that person, trust becomes stable. Then we have dissolution. So trust declines when there is any failure or data breach happening. So these are all the phases of trust which will happen in general. All these are general topics you can write generally also. Next we have types of trust. So we have deterrence based trust. So here trust is based on the belief that penalties for breaching the trust will have potential benefits from the dishonest behavior. So this is one sort of trust which you have. Then we have calculus based trust. So here the trust is based on the belief that cooperation benefits both the parties here. That's why you're calculatively understanding that it will benefit both the parties. Thereby you're believing it. Then we have relational trust. So relational trust will develop over time through repeated positive interactions based on the dependability and reliability aspect. Next we have is trust in online environments. So especially in internet, trust has become a very complex topic. It is very difficult to trust anyone or any application also for that matter over internet. So the anonymity and lack of identity transparency will reduce the trust, as it becomes difficult to access the true nature of any entity, be it human or the software. It is very difficult to understand that your true nature, right? So without the identifiable characteristics or accountability, the ability to trust becomes compromised. So you end up trusting someone who's not trustworthy. So you end up trusting a third party who claims to be a safe or a reliable person. So all that can happen over internet. So that's why trust in online environments is very difficult. So how do we address the trust issues? First one is access the control. So there are mechanisms which are required to prevent the unauthorized access and thereby protect our data. Then we have identity transparency. That is, I have to ensure that if I'm having a conversation with you, so I have to ensure that you should know what I am, and you should know my details, and I should know your details. So that's how trust. That's how the identity transparency is established. So this can be achieved through the biometric information, digital signatures, certificates, and also I'm speaking this from the cloud perspective. Okay, then you have surveillance. So the ongoing monitoring of systems through detection, logging, auditing will ensure that actions could be traced and reviewed. Thereby, it will have proper surveillance and it will foster accountability aspect also. Then we have mechanism for building trust. So first one is credentials. So digital credentials, like digital signature, proof, ID, all that should be used. For example, if you're claiming to be a doctor, your doctor certificates should be available. Your digital signature should be available to verify whether you're true doctor or whatever name you have specified in your certificate, is it matching with your name or not. To check all those general things, we need the credentials. Then we have policies. So trust policies outline the conditions under which the trust is guaranteed, and specify actions to take whether conditions are met or violated. So here we often require the verification of credentials to happen. So thereby policies are again very important. Next we have is the reputation. So reputation is built over time based on the interactions with an entity. So positive or negative history will influence me to take decisions accordingly. So recommendation or reviews from other trusted parties also also improve the reputation of a cloud service provider or something, right? So these are few topics. Next we have is trust in cloud services. So trust in cloud services is again a important aspect. So generally we spoke about trust in online environments here. When we are speaking of particularly cloud, so trust is based on the service provider's reliability and how well he'll meet my specific or specified requirements. So a trust of A to B for a service X is based on A's belief that B will reliably perform X operation within a given context. So trust in cloud computing will completely depend on the transparency, security, and performance aspect. So these three are the driving factors for trust. So building trust and maintaining the trust. So firstly, identity verification should be there. I have to check through the digital signatures, and IDs should be provided. Then monitoring and auditing. So regular monitoring will help us to perform the reports, and thereby auditing also is required. Then we have policy adherence. So policy to check the credentials, policy to have strict rules. All those things are very important. Then we have reputation management. That is by considering the reviews of other trusted members, or having a conversation or having interaction with the entity over time will influence the trust decisions, be it positive or negative. It will build over the time over interactions. So this was about the trust in cloud services. Operating system security in cloud computing. So we know operating system plays a very important role in securing the hardware resources and the applications that share the resources in the computing environment. So it is very important to safeguard the operating system, because depending on the operating system, only multiple access would be provided to various users, right? So there are chances of some user misusing the content or the data which is present here. So in cloud computing, operating system is very essential for maintaining the data integrity, confidentiality, and protecting the applications from any malicious attacks happening. So the threat to operating system has been expanding, because as in when the technology is growing, there have been sophisticated attacks happening. So attacks even targeting the personal devices like tablets, Samsungs, and computers are also there in the market these days. So looking at the key aspects, first one we have is access control. So operating system controls the access to the system objects. So it will make sure that only those people who have the authority or authorized people can be able to access the resources. Access the resources, especially the critical resources. Next, we have authentication. Authentication is checking the identity. So, like I should check your identity before giving you the access. So that's what authentication means. Then we have cryptographic policies. That is, operating system will define the cryptographic policies to protect the data confidentiality, and it will make sure that the information is properly encrypted and secure. So these are the key aspects. Next, we have is mandatory versus the discretionary security. So mandatory means there are strict rules and regulations, policies that are set by the system administrator. So these rules or these policies will tell us how the rules are assigned to users and applications. So the trusted applications are confined to specific security domains, and they can only access the resources which are necessary for their function. So we are restricting the access here. Coming to the discretionary security. So here the security aspect is in the hands of users. So there could be, because if the user is negligent, then there could be security breaches happening here. And here, not just that, even the user has the authority to alter the policies, thereby compromising the security also. So if he has lack of knowledge, then there is definitely security breach going to happen in your operating system. Next, we have trusted applications and privileges. So applications that will perform those applications who perform the critical security functions are called as trusted applications. So these applications are restricted to minimum privileges. So we are minimizing the privileges given to the applications. Thereby, by minimizing the privileges, we are preventing any abuse or exploitation which could happen. Example here is the type enforcement. Type enforcement is a type of security measure where we will limit the privileges which are given to the applications. Thereby, we are avoiding any unauthorized access to make use of the data present inside the applications. Next, we have solutions for enhanced OS. Next, we have trusted paths and security mechanisms. So, trusted path means for security interactions between the user and the trusted software, we make use of trusted path. So, it will ensure that there is secure interaction happening. So, without this path, the malicious software can enter through the trusted software, and it will deteriorate the system security. So the trusted path will allow for secure login authentication and password changes, and enforcer and decider component will have the enforcing security policies. It will manage all the access control mechanisms and all of that. Next, we have for enhanced OS security. First one is decomposing mechanisms. So dividing the complex task into small processes or components, like the enforcer and decider for access control, can thereby enhance the OS security. Then we have sandboxing. So by making use of environments like Java Sandbox, we can restrict the unauthorized actions to happen. Then we have cloud box platforms. So these platforms are embedded using the cryptographic keys, thereby authenticity, confidentiality, all those things are maintained here. Then we have application specific security. So here applications above the operating system layer will implement better security. For example, the digital signatures for e-commerce transactions and all. So these are the solutions for enhanced operating system security. Speaking of the limitations, first one is the commodity operating software will offer low assurance and they are susceptible to attacks which can happen easily. Then we have application compromise. That is, compromising one application can endanger the entire platform together. Then you have weak authentication mechanism. So there are weak authentication mechanisms, and because of that, the loss of trusted path, or these two are the reasons why the vulnerabilities can happen. So this was about the operating system security in cloud computing. So it's again a very easy topic, generalized topic, you can write it very easily. Next we have is virtual machine security. So virtual machine security revolves around the safeguarding of virtualized environment from threats at virtual machine monitor and individual virtual machine levels. So we have to safeguard the virtual machine from threats. So these threats could arise because of the VMM, or it could be because of the individual VMs. So virtual machine plays a very important role in cloud environment. So it offers isolation between the virtual machines, and thereby it also has certain vulnerabilities. So looking at the virtual machine security models, in the traditional system of VM model, the virtual machine monitor VMM will enforce security by controlling the access to the hardware and isolating the virtual machines from each other. So you are completely isolating the hardware and you are controlling the access also here. Speaking of the hybrid and hosted virtual machines, they are less secure because here the entire system security is dependent on the host operating system. We have covered all these topics in second module. So if you have not watched my second module explanation, do check that out. And if you're new to my channel, do refer the cloud computing playlist. We have discussed module wise important questions, so do check that out. Next, we have the virtual machine can have their security managed by the virtual machine model or the dedicated security VM. So a trusted computing base, that is TCB, is very important for maintaining the security in virtualized environments. So the VMM and VM, the virtual machine monitor and virtual machines, are can be used to maintain the security with the help of TCB here, trusted computing base. Looking at the virtual machine monitor isolation. So VMM will ensure the strict isolation of VMs than the traditional OS processes. So it will protect the VM from malicious actions by other VMs. So here the challenge is we have to manage higher level security services. So we know that VMM primarily addresses the low level system functions, but then when you're speaking of the high level functions, high level services, they are more abstract and it is difficult to enforce them through the VMM here. Next, we have security features of virtualization. First one is we have VM cloning and replication. So cloning means ability to replicate or clone the VMs will enhance the security here because it will allow for testing the suspicious applications in controlled and isolated environment. Thereby, you can safeguard your actual VM or actual operating system. Then it has communication and isolation. So inter VM communication is faster compared to the physical machines because you can easily communicate there firstly, and then thereby it is also enhance your security aspect. So because it is isolating the processes here. Next we have threat attacks. So in threat attacks we have sophisticated attacks. Sophisticated attacks means attacker will try to avoid the VM honeypots. He'll try to access the VM logs to steal the sensitive information. It could be the cryptographic keys and all. So here log files must be safely protected here. Then we have security trade-offs. So here virtualization will provide enhanced security, but in case of higher hardware costs and development overhead are will happen here. They are bound to happen here. So there is chances of security trade-off happening here also because of the overhead which is happening. Next we have VM based intrusion detection and prevention. So VM based intrusion detection systems, that is IDS, such as the livewire and siren, use VM isolation, inspection and interposition to detect the attacks. VM also supports the intrusion protection system like SVFS and NetTop, which will focus on protecting against the threats before they impact the entire system. So before only you are preventing it and initially you are detecting it. So thereby you can save your VM from getting attacked or from the attacker stealing the data from your VM. We have VMM based threats here. So first one we have is resource starvation. That is the rogue VMs can bypass the resource limits, thereby it will lead to starvation of the VM machines here. Next we have side channel attacks. That is, if there is a poor isolation between the VMs, it can allow for malicious VMs to attack each other. Thereby, side channel attacks can happen. Next, we have buffer overflow. That is, vulnerability with the VMM can be exploited by the attackers. Thereby, buffer overflow can happen here. Next, we have is VM-based threats. In that first one we have is rogue VMs. So here, unauthorized VMs can be created and launched with insecure settings. Then we have tampered VM images. That is, VMs may make use of the insecure or compromised images, thereby increasing the security risks. Here we have figure of virtual services provided by the VMM. This is specific for VMM. So like the VMM here will control the entire hardware access. It will manage the interactions between the guest virtual machines, and it will also provide the security also here to ensure isolation is happening and then integration between the components is happening here. Coming to this figure, it is about the alternative architecture where we have a dedicated security services VM which will handle the security task here. Along with that, we have the trusted computing base also here, right? So here there is an additional layer which will enhance the security, especially for managing the sensitive data, and if there are any rules and regulations, policies kind of things are all taken care here. There is a dedicated security VM in the second figure. Next topic which we have is security risks which are posed by sharing images in the cloud environment. So when we are using the cloud services like AWS, sharing images particularly through the resources like AMI. AMI stands for Amazon machine images, AMI. So when you're sharing the resources through AI, when you're sharing the images through resources like AMI, there are chances of attacks or vulnerabilities, even if the AWS is a trusted cloud provider, right? Even in case of AWS also, there are chances of vulnerabilities to happen. So shared AMS, shared Amazon machine images, often tempting for less experienced users, can harbor significant security risks, especially if they come from an unauthorized or untrusted malicious sources. So there are chances of vulnerabilities or attacks to happen when we are dealing with the less experienced users and the data or the content is coming from malicious sources. So we'll look into the image creation process. So in order to create AMI, there are certain processes. So first one is creation of image. So starting from a running system, another AMI or VM image is used to make the image here. Next we have bundling. So the image is compressed here, encrypted and split into different small segments which have to be uploaded further. After that, we have user instantiation. So here the user will specify the resources, whatever the credentials he want, or what is the configuration, resource setting, all those things to instantiate the AMI. So the process of sharing images can introduce various security risks because of the leftover sensitive data and improper configurations. We have the AMI security audits here. So a security audit of 5,300 AMIs revealed several critical security risks, out of which 98% of the Windows AMIs and 58% of Linux AMIs had critical vulnerabilities, including the remote code execution risks. So these vulnerabilities were often outdated, with many images being several years old, and sometimes they lack the necessary patches. Speaking of the backdoors and credentials, many Linux AMIs have their leftover credentials here, like the passwords, keys, and all. So this will allow the unauthorized users to log in running into the instances. Then some AMIs will have the information about the SSH keys. So this will help them to log in remotely without any detection happening. Even the password hashes which are present in the AMIs can be cracked using many algorithms. Next we have man in middle attacks. So if you're storing the images, then there is definitely chance of man in middle attack to happen by exploring the shared SSH keys over internet. Then we have unsolicited connections. So some AMIs were configured to send information to external agents. So there are chances of information leak to happen, right? So the malicious attackers can make use of these informations, and then further unsolicited connections could be established. Then we have the malware. So it includes trojans, which was discovered in some window AMIs. So these trojans could facilitate key logging, data theft, process monitoring, compromising the privacy and security of the users. Next, we have privacy risk for image creators. So creators of shared AMIs risk, all these are the risks. First one is private key, IP address, browser, and shell history. So all the data of private key, IP addresses, browser history, and shell history are at a risk of whoever creates the image. Then we have API keys. So that is malicious actors can extract the sensitive data like API keys. So they can further have the unauthorized cloud service usage or access the SSH keys and further make use of it. Then we have deleted files. So deleted files in AMI can also be used. They can be recovered using the standard utilities, and then I can make use of the sensitive information which is present in these deleted files. Looking at the key recommendations, first one is secure image creation. So we should make use of tools like shred, scrub, or wipe to ensure that sensitive data is securely deleted before creating a image. We should avoid leaking of private keys, IP addresses, or any sensitive information within the image files. And then we should also ensure that cloud init scripts are properly configured, and the SSH keys should not be able to access easily. Then we have vulnerability management, that is regular updates and patch AMIs will make sure that the critical security vulnerabilities are dealt here. So proper vulnerability audits or AMI checking should be done regularly. Thereby you can avoid the vulnerability cases. Then we have image auditing. So users should audit the shared images to ensure there are no backdoors. So we should make use of the security tools to inspect the AMIs if there are any malware present here or unexpected outgoing connections are happening here or not. Then we have control access to AMI repositories. So we have to restrict the access to image repositories and ensure that only the authorized person can have access here. Next we have is security risk posed by management operating system. So there is significant amount of security risk posed by the management operating system in virtualization environment, especially when those are relying on the hypervisors like Zen. So we are speaking about the management operating system from the hypervisor perspective. Example here is the Zen hypervisor. So we'll look into what are the key risks here. So the trusted computing base, we have seen TCB. So in virtualized environment, TCB includes the hardware, hypervisor, and it has the management OS that is which will run in the DOM OO, domain 0, right? So these hypervisors will provide isolation between the virtual machines. The management operating system is crucial component and it can introduce vulnerabilities. In case of Zen, this DOM 0 will manage the virtual machine creation, IO, device emulation, and other administrative tasks. Next, we have vulnerabilities in management OS. So a study of Zen found out that most of the attacks targeted the service components of management OS and not on the hypervisor itself. So this is, we can say that the management OS is vulnerable to attacks which can happen in general. Next we have the potential malicious actions by DOM 0. So a compromised DOM 0 can perform several harmful actions. So first one is denial of service. It can prevent a VM machine from starting or alter kernel of guest operating system or to monitor the or controlling the applications. Then we have manipulating the memory mapping and virtual CPU states. Thereby, you are decreasing the integrity of the virtual machines here. Next, we have communication risk. So during the runtime, the domain 0 will initiate communication between the guest operating systems. So these guest operating systems, along with that, external operating systems are also connected via device drivers. So this communication is usually not secured enough, and there are chances of extraction of sensitive information which can happen. Next we have is critical role of Zen store. So Zen store is a crucial component or a critical component for maintaining the state of system. So it can be targeted by the malicious VMs to deny the access to the other VMs or even gain unauthorized access to the memory. Next we have is protection requirement for the domain 0. So first one is memory sharing. So DOM 0 should be restricted from accessing the memory of DOM unless it is initiated by the hypercall. If not, memory should not be shared. Then we have the hypercall restrictions. So security critical hypercalls should be tightly controlled. Like certain hypercalls can cause harm to the domain U. So like foreign mapping or debugging hypercalls should be monitored, and if possible they have to be restricted completely. Next we have is ensure confidentiality and integrity. So by making use of the virtual CPU registers and memory, so they should be encrypted during the save and restore operations. Next we have is performance overhead. So increased security measures such as the encrypted memory or encrypted virtual CPU states can also lead to significant overhead. Thereby, yes, security is important, but then increased security measures also can lead to problems. So suppose if you are taking time to restore or save a particular application, it might take 1 second, and if the security is increased to a great extent, then it might take 2.5 times the actual time which was required to do the same operation. So again, performance overhead is also a protection requirement, yet it is a concern also. Next we have is this figure, the trusted computing base of Zen based environment, which include the hardware Zen and the management operating system running in DOM 0. The management operating system supports administrative tools, live migration, device drivers, and device emulators. Guest operating system and applications running under it reside in DOM 0. So DOM U, it will reside in DOM U. So we have hardware firstly. So hardware will have all the physical machines at the bottom. Then we have Zen is the hypervisor. So a lightweight layer where a virtualization process happens, all the virtualized hardware and managing the guest virtual machines, all that is present here. So domain 0, control interface, virtual access CPU, virtual memory, virtual network, virtual block devices, all these things are there. Then we have the managing operating system, that is domain 0. So here the privilege management of operating systems happen, like administrative tools like migration, device drivers, and device emulation. Next, here we have the DOM U, that is the guest operating system, where the virtual machines which are running on top of Zen with their own operating system here and applications. So these things should be completely isolated from each other by the hypervisor. So the security of this entire virtualized environment is dependent not only on the hypervisor but also on the security of the management operating system, and the communications between the DOM0 and DOM-U are managed here. So this was about the management OS, security risks. So we have tried covering all the important topics of fourth module. I would say that fourth module has pretty limited topics, nearly 6 to 7 topics, and yeah, it is a scoring module. I would say don't leave this module and stay tuned. Fifth module will be updated pretty soon. Thank you.